Hello, everyone. Hello, 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 hello. Our project, as you may have guessed from the logo on the bottom left, was building Pacman. So we wanted to recreate the famous 80s arcade game in 2 weeks while using as little framework as possible, which is what Kay touched on right now. The aim was to learn a lot and manage to implement what we learned in the last 12 weeks here about writing code and having something to show for this presentation that hopefully you might or not enjoy. We're going to tell you about the journey. We're going to tell you about why we chose to do this project in particular, how we organize the architecture of the code, as well as some animation talk, something about our movement, code, and MVP, and game AI at the end.
So yeah, why did we decide to build Pacman? Well, I guess first off, why did we decide to build a game in the first place? Basically, games are fun and we like them. So we decided to build one. But why Pacman? Well, first off, we decided we just wanted to build a game that was known. This was mostly so that we could spend all of our time designing our code and our code architecture rather than designing the game itself. We figured that if we were sort of deciding on what we wanted our character to look like or what our game mechanics were going to be, that would take time away from writing good code. So we decided, first off, to pick a game that already existed. We decided on Pacman because we thought it would be complicated enough to provide a challenge for 2 weeks, but also simple enough that we would actually have something to show for it at the end of the 2 weeks. And to go deeper into why we decided not to use any libraries or frameworks, they're great for more experienced developers to get their projects off the ground quickly, but when you're trying to learn, and you've only been doing this 12 weeks, they obscure parts of the code and reduce your understanding of the project when you have loads of bits of code that you haven't actually written. So we really wanted to do all of this ourselves and do as much programming in these last 2 weeks as possible.
So for our tech stack, we used pure JavaScript, HTML5 canvas, CSS, and we used Node.js for our server. We didn't even use any Node packages. We didn't use anything like Express or anything. So for our testing suite, we used Karma, Jasmine, Phantom.js, and we used Require.js to make all of those technologies work very well with each other. So our project architecture. So throughout Makers Academy, we learned a lot about programming. We learned how to write clean code. We learned different programming concepts. And one of those was object-oriented programming. So the whole idea of object-oriented programming is to break apart complex problems into smaller and reusable ones. And this is done by taking your code and breaking it down into smaller chunks, which are the objects, and then using those objects with other pre-existing objects. So to give an example of this, is say you're driving in your car and suddenly your music breaks down. So because the car is made out of like different smaller objects, so it's made out of like the tires, the doors, and the engine. You know exactly where to look for your problem. So if it's your music that it broke down, you're not going to look at your tires. You're not going to check out your tire or your engines. You know exactly where to look. You're going to look at your radio or stereo object because that's where the music functionality is handled. So we took this concept that we learned, that we were taught in Makers Academy, and we took it and we tried to practice it in our project. And we found that the results were incredible. Like it really helped us add more functionality a lot easier. And this also allowed us to work on different parts of our project at the same time. And it helped us achieve what we have today.
Hi. So MVP, yeah, so we kind of knew what the end product was, kind of debunks the idea of an MVP in a traditional sense. So our MVP kind of came down to feasibility. And basically, after lots of talks, we kind of decided we just wanted something where we weren't going to look really stupid when we're standing in front of you right now. And basically came up with this list, and as you probably see from the video, the last one being, yeah, not so, didn't go so well, but we got there in the end. So how do we go about building said MVP? Well, first off, you kind of get the animation thing going, right? Yeah, you got a little greedy Pac-Man running around the screen trying to eat stuff, and you kind of need to see what he's doing. And so we've got a little video here to kind of highlight what it's meaning, because basically all animation is this drawing really, really fast, clear the screen, draw really, really fast, and again, and again, and again. The problem we started getting, though, is when you start drawing lots of objects really, really fast, the computer starts getting a bit grumpy with you. So we had a lot of problems dealing with efficiency, slowing things down, and we had to kind of break it up, turn around and say, right, draw that really, really fast, but just hold off a little bit. Off it went. Next problems was positioning. Paul's going to talk you through that in a second, but obviously you can probably tell it's kind of drawing in a different place each time. So that, again, came with its own little problems. And animating the boy and the company, otherwise known as a ghost, something some of you may know about, but it's basically sprites. It just grabs one particular image, it draws that, clears the screen, grabs the next one on the line, draws that. And it kind of gives the impression, even though it's not, of Pac-Man doing that, eating away, which he enjoys. Anyway, on to the next.
Right, so to build the movement, we started looking at various Pac-Man games that we found online, and we would kind of looking at a specific thing Pac-Man could do, we'd start reverse engineering to try and make it work for our Pac-Man. So we kind of got into this little bit of a cycle of just observing, trying to write, and then failing. Really, the Pac-Man wouldn't really do what we wanted him to do. So something like wall collision, which we thought is just like one thing, just collide with a wall, just, you know, can't go through the wall. We realized that it was actually a bunch of different little concepts, like slowing down, stopping, and then recognizing there's a wall there. So breaking those problems into smaller ones really helped to actually figure out the math of these little chunks to build the bigger features. Once we would get something that looked a little bit like a Pac-Man, the problem would be just our code looks terrible. It's really convoluted, it's chaotic, it's going to be really hard to build upon. So a lot of refactoring, a lot of really thinking about good practice of code to try and make this as good code as possible, pretty much.
So to talk a little bit about the game AI and in specific the Pac-Man ghosts. There was an interesting challenge with the Pacman ghosts in that there's a lot of very good documentation on how they behave. So we wanted to try and mimic that as close as possible. The first thing that was actually a lot harder than we struggled with is Pacman ghosts can't voluntarily go backwards. And that was a lot more of a struggle than we thought it was going to be. The solution we came up with is that when a ghost is in a square on the grid, it looks in each direction, up, down, left, and right, and looks what's there. So if it finds a wall, it says can't go that way. If it finds that it's the reverse direction, it says it can't go that way. And then it will pick from the remaining paths to go to its target square. The Pacman ghosts also have 3 different modes. They have the hunt mode, the scatter mode, and the frightened mode. All the ghosts will start in scatter mode at the beginning of the game, and then proceed to hunt mode. And they all hunt in slightly different ways. The red ghost will always hunt the tile that Pac-Man is on. The pink ghost will try and intercept 4 ahead of Pac-Man. The orange ghost will hunt Pac-Man until he gets within 8 tiles of Pac-Man, and then he'll run away to the bottom left corner because he's scared. And the blue ghost will use a combination of the red ghost position and Pac-Man position to get its target square. And we thought this would be really difficult to implement, but due to how our code is organized and all the objects, we were easily able to get the information that we needed and sort out the ghost AI fairly easily, actually. So it wasn't as hard as it is. And now we're going to have a short little demo where hopefully you'll see this in action in HD, kinda. 60 frames a second.
Quite a long time.
Layman and I played it a lot more, so we're much better. Walk out, walk out. To conclude, we'll talk a little bit about how things went. I mean, the code was complex by the end. There were a lot of elements. There were a lot of things interacting with each other, both on the canvas and in the code base. But things got a little more complicated when kind of communication between the team went a little bit bad. I would say that a little bit like the four ghosts in Pacman were four very different men, but we eventually realized we had a shared goal of chasing the Pac-Man, so it came together somewhat nicely.
We'll talk about some of the successes, and we're really happy that we achieved. So we're really happy that we, with this project, we really grasped the full understanding of object-oriented design, and it's something we're really proud of that we used it in our code. We also, one of the big struggles that we had, as Bertie talked about the Ghost AI and how complicated it was, and that was one of our biggest successes, was to figure out that and implement that into our game. And also, yeah, we built Pacman. Yeah.
Yeah, so thanks. Kind of the summary. So those guys back in the 80s, they were pretty smart, right? Didn't see that one coming. But I just want to say a quick thank you. Wanted to say thank you to our coach, Kay. Marvelous job. Thank you very much. Thank you to the April 2017 cohort. Legends. And thank you to the teammates. There's Paul, Slalom, myself, Henry, and Bertie. Thank you, guys.